In this video, we're going to cover section 6.3, sigma notation and summations. So if we have a sequence 12, 15, 18, and 21, then its corresponding series or summation would be 12 plus 15 plus 18 plus 21. So a summation is just adding up terms of a sequence. So to help us write this more compactly, we use sigma notation. So if we kept going and we just had, let's say, 50 terms, we're not going to want to list out all 50 terms and show that we're adding them. So what we would do instead is we would use the sigma notation. So the sigma notation has the Greek letter sigma right here, and that means that we're going to find the sum of everything. Okay? With sigma notation, we have this down here, which means we are going to be plugging this number in to our function. So this is going to be the first number we plug in. Then what we're plugging it into is this piece right here, and this is going to end up being some function or equation. And we plug them in. And then this up here is going to be the very last number that you plug in. And so when you plug in numbers into this function, it's going to give you the terms of the sequence that you would add up. So in our first example, we're going to rewrite each series just as a sequence to practice plugging in numbers. So in part A, we have the summation from 0 to 5 of 4n. So this right here is our function. We are going to be plugging numbers in for the variable n. The first number we plug in is going to be 0. So this is where we're going to start. And the very last number we plug in is going to be 5. So we're going to plug in 0, 1, 2, 3, 4, and 5. So what this looks like is we're going to have 4 times 0. Then we have 4 times 1. And then we have 4 times 2. 4 times 3. 4 times 4. And lastly, 4 times 5. So this is how we would get the terms for the sequence. So we would have 0, 1, 4, 8, 12, 16, and 20. So if we need to determine the sequence that would go with this summation, then this is what we would do. Now, if we wanted to evaluate the summation, we would take 4 or 0 plus 4 plus 8 plus 12 plus 16 plus 22 or plus 20. Okay, so you would end up adding all of these numbers in order to get the total for the summation. So that's what it would equal if we were actually evaluating the summation. But right now, we just want to be able to take the summation and turn it into a sequence, or you should be able to identify that this sequence goes with this summation. Okay, so part B, we have the summation from n equals 1 to 4 of n plus 5. So here's our function. We are plugging numbers in for n, and we're going to start by plugging in the number 1, and we're going to stop at plugging in the number 4. So we have 1 plus 5. Then we have 2 plus 5. Then we have 3 plus 5. Then we have 4 plus 5. So this sequence would end up being 6, 7, 8, and 9. looking at the last one. If you want to pause it and try it yourself, you can do so. But we have the function 2n. We're going to start by plugging in the number 7. And we're going to stop by plugging in the number 10. So notice now in our function that our variable is the exponent. So we're going to have 2 to the 7th power, 2 to the 8th power, 2 to the 9th power, and 2 to the 10th power. So when we evaluate this, we get 128, 256, 512, and 1024. And that would be the sequence that corresponds to that summation. So again, in this first example, we have not evaluated the sequence, the evaluation, or we have not evaluated the summation. That would be if we add all of these terms together. Right now, we're just practicing transferring it to a sequence from a summation. Okay. Now in example 2, we are going to actually evaluate the sequence, or the series, the summation. So in order to do that, I have typed up your calculator steps. So you're going to press alpha window number 2, and then you just have to make sure that you change your variables to the letter X. So in example 1, make sure you grab a calculator so you can type this in. The only thing that we're changing is that our variable is going to be X. And I think I have a calculator that I can pull up. Let's see if it works. Oh, nope. So I think I messed up the calculator. So I'm not going to, oh, there we go. Let's see. Let me go to the full screen. Here we go. Okay, so we're going to hit alpha window. So hit alpha first, then window, and then, oh, let me get out of that screen. There we go. So alpha window 2, and we're going to type in the summation exactly as we see it. So we have X equals 1. Up at the top, we're going to type in 8. In the parentheses, we're going to type in 2 times negative 3 to the X minus 1 power. We press enter, and we get our answer, negative 3,280. So let me go back. So this equals negative 3,280. Boom. That's it. That's the evaluation. So if we were to plug in 1, plug in 2, 3, 4, 5, 6, 7, and 8, and we took all those numbers and we added them together, then we would get negative 3,280. So moving on to B and C. So I'm going to show you how to type them both in, and then I'll write the answers. So for B, we have alpha window 2, X equals, this one is going to start at 1. It's going to go to 4, and we have 2x. Press enter, you get 20. Boom, that's it. For letter C, alpha window 2, we have x equals 4 to 7 of x minus 4. Press enter, we get 6. And that's it. That's all you have to do to type these in. So we got 20 for this one and 6 for this one. And again, just a reminder that we end up changing our variables to the letter X. It just makes it easier on us. Okay? So now, this next one is a review question. So we want to find the solutions to the given polynomial inequality. So first thing we need to do is we need to take each one of these factors, x minus 3, x plus 4, and x minus 6, and set it equal to 0. And so then we would solve each equation by doing the opposite. So I'm going to start by adding 3 to both sides, and I get x equals 3. Then I subtract 4 from both sides, and I get x equals negative 4. And then I add 6 to both sides, and I get x equals 6. So now what I want us to do is I want us to go to the calculator so we can graph it in the calculator, and then we're going to sketch a graph of what it looks like. In the calculator, we're going to be typing in this part only right here so we can see what it looks like. So I'm going to switch back over to my calculator. I'm going to go to y equals. I'm going to type this in. So we have x minus 3, x plus 4, x minus 6. So it looks like that. And I hit graph. So right now it doesn't look like much, so I may need to zoom out. In order to zoom out, you can go over here and mess with your windows. Your X-min and your X-max will change your X values, your X-axis. You can make it bigger or smaller. Your Y-min and your Y-max changes the Y values. Or you can just go over to zoom, and number 3 says zoom out, and then you just press enter and it zooms out for you. If you want to zoom out again, you go zoom 3. Press enter, it zooms out. So that's maybe a little too much to zoom out. So if I go back, I can zoom in by hitting zoom 2 and pressing enter, and it zooms in a little bit. But again, the most efficient way might be to change the window settings. But again, you're just going to have to make sure you are comfortable pressing buttons on the calculator. But all I need is the general shape. So it looks like it's starting down on the left side, and it's going up and then back down. So I can sketch a rough sketch of what that looks like in our notes. So it looks like something like this, this to this. It doesn't have to be perfect, but something like that. What we do know is that this x-intercept is negative 4, this x-intercept is 3, and this x-intercept is 6. And you're probably thinking, well, how do you know that? Well, we found those x values up here, and if we're thinking logically, all I did was put them in order from least to greatest, and that's how it's going to cross the x-axis. Now, what we're looking for, okay, and what we need to know is everything right here. So that little piece right there tells us how to get our answer. So first off, because it says it's less than 0, we want what is below the x-axis. And it also tells us that we will be using parentheses because there's no line underneath. So if I'm looking at my graph, that means I want this piece, and I want this piece to this piece. And so now for my solution set, it's just writing the domain of those pieces. So if I'm going from the left to the right, I would start at negative infinity, and I would travel along until I get to negative 4, and then that's when it stops being below the x-axis. So my first interval is negative infinity to negative 4. Then the next piece would be from 3, the x value of 3, and it goes along until it gets to 6, and then it goes back above. So our last interval is going to be 3 to 6. And that's all you would have to be able to write. So this time you're not going to have to graph it on a number line. This last one is to review our log properties. So our log properties, we want to use the properties of logs to expand the given expression. So first thing we need to remember is that we have 1, 2, 3 variables, which means when we expand it, we should have 3 of the natural log, and that's the one we're using. If it was log or log based on any number, we would have 3 of those, but we're using the natural log. So if it's on top, like it is here, that means there's going to be a plus sign between each of those natural logs. So the tops get plus signs. If it's on bottom, like this z, then it's going to get a minus sign. So, first thing I'm going to do is I'm going to expand it, and each variable is going to get its own natural log. And when I switch to the new one, I'm going to make sure I use the right sign. So when I go from x to the next one, it's going to have a plus sign. Then I have the natural log of the square root of y. And now when I go to z, it's going to have a minus sign, and it's the natural log of z to the 8th. The next thing I need to focus on is this right here, this square root of y. So we need to remember that the square root of y can also be written as y to the 1/2 power. So that's what we're going to do for this, is we're going to rewrite it, and instead of saying the square root of y, we're going to change it to y to the 1/2 power. And then I have everything else staying the same. From here, what we need to do is we need to take each of these exponents and we need to drop it down in front of its respected log. So we would have 4 natural log of x plus 1/2 natural log of y minus 8 natural log of z. And this would now be fully expanded. So if you have any questions over anything that was covered in these notes, please make sure you write them down and you ask in class.